In this video, we want to disprove that for all positive integers n squared plus 3n plus 2 is prime. So in order to disprove this, we need to first establish that n is some positive integer. So let n be an integer. Such that n is greater than 0. Right, we want to show that n squared plus 3n plus 2 is prime. So we could observe n squared plus 3n plus 2. We could factor this. As n plus 1 times n plus 2 by algebra. And then, based upon this, since n itself was an integer, we know that, let's see, since n was an integer, so since n was an integer, n squared plus 3n plus 2 is also an integer. Since the integers are closed under both multiplication and addition. Which also yields the fact that n plus 1 times n plus 2 is an integer, and that n plus 1 is an integer, and so is n plus 2 an integer. But since all of those there are integers, we know we could say that n itself, right, n itself has to be greater than 1. Greater than or equal to 1 by our given statement above. Likewise, because of this, n plus 1 has to be strictly bigger than 1, since if n itself was 1, n plus 1 is already greater than 1. And so is n plus 2, also greater than 1. But since n plus 1 and n plus 2 are both greater than 1, then we know then, my mouse wants to work, n plus 1 times n plus 2 has to be greater than 1. Which also means that n squared plus 3n plus 2 is also greater than 1. So because we showed that n squared plus 3n plus 2 is not only factored down to a product of integers, but that those integers are also greater than 1. So because of this, we have shown that n squared plus 3n plus 2 can't be prime due to that fact. So n squared plus 3n plus 2 cannot be prime. Since the only way that a prime number, we can have a prime number, is if it's a fact, is if from the factors of n, from that prime number, it has to be 1 in itself. But since we've shown that n plus 1 and n plus 2 are both strictly greater than 1, neither of which are 1, that means that particular polynomial cannot be prime. Thank you.